All right, I think we can get started. Welcome, everyone. Good afternoon. Thank you for joining us. Today, we will talk about Amazon EC2 Systems Manager, which is a new service that was announced earlier today. Some of you may have heard about it at the keynote. And I'm joined here today with Tim. Tim Nicholas is from Xero, and he will talk about how they're using Run Command and some of the tools that we've built to automate their infrastructure. My name is Amjad Hussain. I'm a senior manager at Amazon EC2. And one of the things that we wanted to focus on in this talk is not just the Systems Manager product, but also how can we leverage the tools that Amazon has provided to help you better manage and configure your infrastructure, especially when you think about larger companies or enterprises that have had they're either moving to the cloud or already have significant workloads that are running in the cloud. How can we better provide products and tooling for those companies? So let's get started. What we'll go over today is I will introduce Systems Manager. We'll go through some of the key capabilities and features that we announced today that are generally available. We will talk about Run Command, State Manager, and Parameter Store, and I'll introduce those and what they do. And we will talk about how Xero is using Run Command and has been using for a while in their IT and in their infrastructure. And then we have a few demos for you, and then there's some FAQs and best practices that we'll share. So let's start by how did we build EC2 Systems Manager, or why did we build EC2 Systems Manager? And we've been talking to a number of you, and I see a lot of, a few familiar faces in the room here. And there are companies, and there are some of you who have a lot of traditional tools and investments that you guys have made. And as we're moving and adopting workloads in the cloud, we've heard feedback repeatedly that some of the existing tooling is not suitable for the cloud scale, as well as some of the best practices in modern DevOps techniques. We've also heard some other recurring themes, things like how do you do change management, or how do you get visibility into the configuration and the changes that are happening on your systems. And another common theme that we keep hearing is that there is complexity around licensing, around cost for some of the tools that some of you are using. So with that, I'd like to go a little bit more deeper into Systems Manager. Like I said before, Systems Manager is a service that we announced earlier today. It's part of Amazon EC2's set of capabilities. And really the way to think about this is it's not just one feature or one service. It's a collection of capabilities that we've announced today that help you better manage and administer your infrastructure at scale. So let's just go right into it. So if you sort of look at what a traditional workload or what a process looks like, you start by deploying and configuring your infrastructure. There is how do you manage, track, and update that infrastructure, and there's some common things that I'll go into. And what we've tried to do is we've tried to build a number of capabilities that help solve various use cases along that pipeline around that sort of life cycle. From your left, Run Command and State Manager. Let's spend a little bit of time on those. Run Command is a feature we launched last year, almost a year ago, and Run Command lets you remotely administer and execute commands at scale. State Manager is a service that lets you, the way I like to describe it, it lets you define a personality of your fleet for your instance. And I'll go into more what State Manager does. On the right-hand side, there is inventory. Think of inventory as software configuration and software information that's on your instances. We provide a simpler way to collect some of that information and provide querying capabilities on top of that. Patching, especially for Windows workloads, is something that we've heard. A number of companies have challenges around how do you make sure your instances are secure? How do you make sure that if you have certain compliance or certain patch criteria that those are met? And so we have announced Patch Manager as a feature for that. Automation. Automation is an interesting one because one of the things that we ourselves struggle with sometimes is our team is responsible for generating a lot of armies, right? And we generate Windows armies, we generate other armies, Amazon machine images, and what we've found is that process can be cumbersome. And we've heard the same feedback from customers and from some of you. And so with automation, what you can do is you can automate some of those common workflows. Things like if you just want to spin up an image, apply certain patches on it, layer your software on it, and then create a new army, the automation service helps with that. In the middle, there's a couple of common services that we've built that you'll see in some of the demos that can be used across the Systems Manager capability set. Things like maintenance windows through which you can define periods or recurring schedules where you can schedule operations, as well as parameter store. Parameter store, which we'll go into much more detail later on, is a lightweight way for you to store information such as configuration data, such as common sensitive information that you can reference it across your other capabilities. So let's go a little bit deeper into Run Command. Run Command, like I said before, actually before we go further, how many of you are familiar with Run Command? Show of hands. Okay, all right, 20%. How many of you have actually used Run Command? All right, 5, 7, 10% maybe. Okay, cool. So Run Command is a service that lets you remotely administer and run commands against a set of instances. It helps you lock down your infrastructure. In the past, in fact, even now, a lot of customers or companies have open-ended SSH or RDP, remote desktop access, open into their boxes. And so with Run Command, you can lock down your environments more. You can provide better, finer-grained access control, and you can customize what type of actions and operations are permitted on certain or specific instances. Run Command also lets you get very detailed information about what's running on the instances and what has executed. Using CloudTrail and some of the other integration points that we've built, you can get historical data. And we've also recently, and I'll go into this a little bit more, we've also recently added the capability to control the rate at which you send commands so that you don't disrupt your fleet while you're rolling out a change or a disruptive action. So let me just spend a little bit of time on how to actually get started and send a command. In this case, I'm using a CLI, and you can see there's a few common concepts that I wanted to go over. The first is a document. So the first thing you do when you're about to send a command is you encapsulate it in a concept that we call a document. Think of document as a JSON representation of the specific action or the specific task that you want to perform. Amazon provides a bunch of documents out of the box, so you can do things like run PowerShell, run a shell script, or configure Windows Update, or you can write your own documents. So that's the first parameter. The second parameter is the target. So after you've defined your intent, you define the target. The target can be either a list of instance IDs, or it can be a tag query. And we'll go into how tag queries work, but the basic idea is you can tag your instances, and then you can send a command to everything that matches that tag criteria. The third option there is a parameter. A parameter is an optional parameter for documents. So some documents can be very closed, right? They do only one specific action, like net stop some service. Some documents can be open-ended, like you give them the specific command that you want to run. Like in this case, you can see I'm running an Amazon-published document called run PowerShell script, and it takes a parameter which is what is it that you want to run. So in this case, you can see that I'm creating a directory under C drive. And the last parameter is an optional capability that we added a few months ago for notification support. So using the notification parameter, what you can do is you can say, when this command is completed and it meets these criteria, send me a notification via SNS. So you can see, like in this case, I will get a notification on the SNS topic that I've provided when the command reaches a successful state. Okay, so we actually talked about most of this stuff, but basically to get started with Run Command, you start with an instance. And one of the things that you'll notice is, if you use run command, is that for Windows instances, we have an agent that we pre-install on default Amazon images. It's called the Amazon SSM agent. It's open source. And so you'll need to have the agent installed and running on your instances. For Linux, we do not install the agent by default, but there is a well-known location that you can go and install and run the agent from. You also need to have an instance profile, an IAM role, attached to your instance. We use this to authenticate and authorize the instance so that we know it's for your account and it's authorized for those commands. So that's the prerequisite. You start with an instance. We already talked about document, which is how you author your intent. And then the next couple of concepts are around commands and command invocation. At a high level, you can think of it this way. If you're running a command, there's a command object, which is the request, and there's an invocation, which are the actual results of the command that you're running. And then we get into detailed status and error reporting. So this is the thing I was just talking about a few slides ago. We have recently added the capability to send a command at scale. Right? And the way you do that is, in the past, you used to have to send commands to individual instances. So you can send it to a specific instance, or you can send it to a list of instance IDs. What we've added now is the ability to send a command to a tag query. This can be quite powerful because what we've found is that a lot of you are actually already tagging your instances based on either department or other grouping constructs. And so having the ability to send a command to a tag can help with that sort of scaling strategy. The other thing that we've added, because we are letting you send command to many more instances now, is we have added the ability to do rate control and error handling on those commands. So for example, you'll see in the last couple of lines there is a parameter for max concurrency, so the maximum number of commands you want to run it in one batch, as well as max errors, which is the number of errors that the command, what is the error threshold beyond which we will stop executing the commands. So you can use this, you can use these two sort of knobs in combination to control how fast you want to go and how quickly do you want to stop. Okay. So setting up your instances. Like I said before, one of the things about Systems Manager as a whole is that it uses the same common agent, which is the Amazon SSM agent. It's written in Go. It's available on open source, and we regularly update it with some of the new capabilities and features that we're building into Systems Manager. Once you register an instance, it starts heartbeating with our Systems Manager service. And you can find out what are the instances that we're aware of, and you can perform operations like updating the agent or figuring out if it hasn't heartbeated in a while. And the other thing that I want to call out is everything I just talked about works on EC2 instances as well as on-premises instances, right? So you can imagine you take the agent, you install it on your on-premises VM or physical bare metal server, and it just gets registered as a managed instance. After that registration or that initial tie-up is done, you can manage that instance just as if it were an EC2 instance. Heartbeats. So here's an example of how you can use an API or a CLI to find out what agents are heartbeating and what is the state of a specific instance. In this example, you can see that there's useful information like, is the agent version latest? And if not, then you can choose to upgrade the agent. Is it heartbeating, which is the ping status, as well as certain platform information such as Windows version, what SKU of Windows, as well as heartbeat information. So that's how you can find out. Now, when I do the demo, I'll go a little bit more into how you can filter and get a holistic view of what are some of the, what is the state of your fleet from an instance perspective. I touched on this briefly, the on-prem support. And it's actually quite simple to set up. The way we register on-premises instances is you install the agent, and you have to create something we call an activation. You can think of activation as a one-time thing that lets you provision a number of on-prem or hybrid servers that you can register with us. So for example, if you look at the screenshot here, I have created a sample activation, and I have said that the limit for this is 10. So that means that using this activation code, I can register up to 10 instances. And then beyond that, when I activate, I will get an activation code that I can use as I'm registering my instances. Okay, customizing commands. So one of the things I mentioned earlier is a systems manager document is a generic concept that is used not just by Run Command, but also by some of the other services I talked about, things like automation service, things like State Manager that we will get to soon. And a document is a simple JSON schema. It has a few key aspects, things like what are the parameters that this document takes? What is the input of the document? It also takes steps. So what are the specific sequence of things that you want to perform? And it also lets you do versioning and editing. So for example, you can edit a document, and you can make a specific version of the document, the one that everyone references and uses. We've also added the capability to share documents. So you can imagine if you have a multi-account scenario, like a large company, you can imagine how one account might have a bunch of documents, and then you share that with specific accounts in the organization. And because documents are AWS resources, you can do fine-grained permission control on it. So you can say something like, Amjad has access to only this one document that does a very specific action, like starting a service or stopping a service or something like that. And here's an example of a JSON sort of format. You can see there's a description, and you'll see how we use this description to visualize it in the console in the CLI. You can see that there is an action, which is the specific step or the action you want to perform, and the specifics of the action. So in this case, I'm just running something called myscript.ps1, and I give it a working directory and an execution timeout. We talked about document sharing before. Just one minor clarification I wanted to do is you can share documents across accounts, and you can share them publicly as well. And that's how Amazon publishes the documents that we have published. All right, so with that, I would like to hand it over to Tim, who will go over how they're using Run Command. Thank you, Tim.
Thank you. So I'm Tim Nicholas, Lead Automation Architect at Xero. For those that don't know, Xero is award-winning cloud accounting software, small and medium businesses. And so Xero started in New Zealand, but we've got offices, including development offices, in New Zealand, Australia, the UK, and here in the US. So we're a global company, both in terms of our customers and our teams. We've got over 860,000 organizations running their accounting through our application and platform. And over the last 2 years, we've sort of started and then completed building a new version of our platform in AWS. And then over sort of 6 months this year, we've migrated all of our applications and all of our data into AWS. So as we migrated into AWS, we took the opportunity to really embrace a code-driven infrastructure. And with the sort of new technology and new architecture comes new challenges. So the first one really was host discovery. We went from having relatively few servers to having very many servers, from hundreds to thousands. And that comes with challenges, obviously, and particularly with a dynamic environment, instances coming and going in a way that wasn't true in our previous infrastructure. We also, with this new code-driven infrastructure, wanted to have ways of integrating our diagnostic and investigative processes into our pipeline tools and making them really take advantage of that code-driven nature. And that applies whether it's adding technical gates to deployment or pulling information into a chat so that people are more informed when they're making decisions, or perhaps maintaining systems via a Lambda function. And a variety of other things. Probably the biggest challenge, though, was network isolation. We really didn't want to rely on privileged network locations for all actions that an administrator might want to do, particularly as we pushed out sort of more responsibility for maintenance to product development teams. Having those positions in the network that had extra special privilege didn't seem like the safest way to go. And in some cases, in a multi-VPC, multi-accounts, multi-region environment, those locations may not even be plausible to exist. So on the left here, you can see sort of a representation of the product application VPCs. And you can see that on the top there is what we call the threat protection zone. It's got a web application firewall for incoming customer traffic and proxy for any outgoing internet access. And on the right, we've got an equivalent setup for where all of our build and continuous integration type systems might be. And they can't talk to each other. Administrators can push code to Git, and they can, with MFA protected access keys, they can talk to the Amazon APIs, but they can't talk directly to those servers inside the application space. And neither can the pipeline tools. So you can see that the Amazon APIs really provide an integration point between all those different things. So there's quite a lot of different use cases that we have for Run Command. I'll just go through a few of them. We use Run Command to validate .NET application configuration inside the environments. So we can reach in from our pipeline tools that do deployments, do releases, might switch a Route 53 entry, and at that last moment, or at any other moment, validate that that configuration is actually correct. And we can do that quite actively and do interesting things, like actually make connections to the databases. Make sure that that connection string is not only syntactically valid, but that actually the DNS resolution is working. The network path is open. The credentials are valid. And get that information back to inform the decision of whether to go ahead or not. We've had situations, pulling code that's run in one set of infrastructure into a new set of infrastructure where you find new and exciting ways that it behaves. So, for example, DNS and connection caching. And using Run Command, we're able to sort of delegate out access to be able to safely reload application pools to clear those caches. We can delegate that to the application development teams, who are actually the right people to be managing the long-term permanent fix, which is really useful. So putting that responsibility for that operational procedure in the hands of the people who've got the long-term code quality and the ability to really fix that permanently. We also wanted to enable services on a sample of machines. In this case, sort of detailed performance monitoring and in-depth analysis things. So we don't want to have it running on everything, but in a system where you've designed and put a lot of effort into making sure that you've got a very consistent, repeatable process to construct these things in a dynamic environment. There's no first one, there's no last one of these things. So you need to have a way of turning on that service on only some. And using Lambda, Lambda and Run Command, looking at defining a set of hosts, and then finding a sample of them and using Run Command to turn on a service on those. Very powerful. And of course, in any even moderately complex environment, you're going to need to do interactive investigation of problems. Things come up, you need to be able to investigate. So I will show you some of what we've done for that now. Very exciting PowerShell terminal window. So firstly, I mentioned discovering your instances. We've got lots and lots of instances. And we've really tried to remove a lot of the frustration of that by having a PowerShell function that matches up with our tagging standard. So we define a server class, and we can look those up from that. And what we do is just pull out the EC2 instance objects that are associated with those, so that we can then have those in the PowerShell pipeline to pass forward to other things. We want to invoke a command on them. In this case, just get service. So we invoke SSM command here is a function that's really wrapping up a bunch of Run Command functionality. It's, Run Command is deliberately asynchronous. It fires off the command, you come back later, you get the results. But that's not really very helpful in a command line situation. You know, when you're running it, wondering if it's ready, running it again. So we have this command to really wrap all that up. Also, if the output is larger than is valid to be returned by the API, it will put it into S3. And the command can then manage pulling that information from S3 so that it's a seamless experience. So if we run this again with a bit more noise, we can see exactly the command that's being run. And it's just that same thing that it was on the command line. You can see it waiting for the results and getting it back. But notice here that the raw output is just text. And in fact, you can see that it's wrapping the IP address really badly. So it's quite hard to use that information to feed into a pipeline to then do more. And we've got PowerShell here. PowerShell's got a great object model, can pass objects through the pipeline, and it's extremely useful. And I'm an ex-Linux guy, and I love PowerShell regular expressions and massaging a whole bunch of text as much as the next guy, but that's no fun. So what we do is really embrace that PowerShell object model and try and keep it all the way through by enabling serialization on the remote host and deserialization on the local end. So you can see here we're using CLI XML, part of PowerShell, so that what we're getting back is not just that text output, it's actually the serialized object. And then locally, it's reconstructed. Hugely helpful. We can now actually query what's in that object. We don't just have what's in the display. We have more richness as well. So we'll just get a few more instances to query. There's all the Windows hosts. And I'm going to run a similar command, but across all of them. Now, note that I'm not using invoke SSM command anymore. I'm using resolve DNS hostname via SSM. This is a function that wraps up a couple of things. First of all, it's using a different run command document. And that's obviously valuable, as was mentioned, because it means you can give out the IAM permissions to run that to a wider range of people than you might just entirely arbitrary PowerShell execution. So you can control the risk profile of a particular document and with who might want access to it. And that means you can actually give people access to information at a much broader level. So we run that. Should have heard it while I was talking. We get some answers. Great. And now, because they're objects, we can group them by the elements of those. So we can see here that we've actually got different answers coming back from different hosts. And that's sort of, that might be a good thing. It might not be a good thing. But you can see that there's lots of times when you might want to investigate why this is. You might want to dig into what's the correlation here that leads to some getting one answer and some getting another. And if these were pure DNS answers, the pure objects that we would get back from Resolve DNS, then they don't have any of the information that you might want pertaining to, which instance ran them, where they are, how those instances were tagged. And so it's really hard to work out what those correlations are. So what we do, this is the deserialized object. We run a get member on it so we can see all the aspects of that object. And you can see we've added some more note properties to it as it's come out of the pipeline. We added instance ID, the generically useful thing to know about this. Where did it come from? But also, quite importantly, the SSM command input object, which is the whole instance object that we had at the other side of the pipeline before. So that means that we've got a lot of information embedded in that. And we can expand out all that information and just munge it onto the top level document so that we can order them and inspect them and look at them however we want. So this is the same object, but with vastly more things on it. Still a DNS record A, but with all this other stuff, right? So now, you saw me organize, query the instances earlier by server class. We can now group these objects and see if we've got a correlation with server class. We sort of do, but it's not a one-to-one thing. They're variable. So we can now, because we've got these objects locally, we can really quickly try different things, see where the strongest correlation is. And it doesn't have to be just tags. It can be other fundamental properties of those instances that it came from. So here, for example, we can see that actually we're just getting different answers in different VPCs. And that might be all you need to know to be able to then go and look at your Route 53 private zones, for example, or your DNS servers, and check out why it is that you're getting different answers in different places. Maybe it's a desired state. Maybe it's what you're intending. But being able to dig into those answers, find the correlation, is really, really powerful. So I hope that that's been a useful insight into how we use Run Command and some of the options that are available there, particularly when integrated strongly into PowerShell. Some of these commands here are part of a module, Cloud Remoting. It's been developed by us. It's available in PSKit, PowerShell Gallery. So yeah, check it out.
All right. Thank you. Thank you, Tim. Thank you.
No problem.
All right. So with that, let's, thank you again, Tim. Thank you. I want to switch over to some of the new features and services that we've built. So the first off, I want to talk about State Manager. State Manager, like I mentioned earlier in the talk, is a new service that we're launching as part of Systems Manager that lets you maintain a consistent state for your fleet, right? The way I like to think of it is, imagine if you start your VMs and your instances and they start with a vanilla a blank slate, right? And then using State Manager, you can give them personality. You can define what they're going to be, what software is installed on them, what policies you want to be applied on those instances, and then you can make sure that they don't drift or deviate from that state. So you can reapply the same policies to make sure that your instances are in a consistent state. The other thing you can do with State Manager is then you can track and aggregate some of that information. So you can see, for example, that 5 nodes out of your fleet are not matching your desired or your intended state, and then you can go and take remediation steps using either Run Command or whatever other remedial tools you might have. State Manager is actually quite similar to Run Command in terms of how some of the core concepts. You start with the document. The same Systems Manager document that we talked about is what you use to define your intent. And this is where you define what are the policies and what are the software and other configuration things that you want on your fleet. So that's the document. The target is where do you want to apply those policies. So that's the document and the target. And then an association is a concept that is the binding between the document and the target. Think of it as a persistent sort of link between the two. You can change a document and your fleet will get updated, and that binding or that sort of mapping is an association. A schedule is a concept that you can apply, or a property you can apply on an association that tells it how often should it reapply itself. And this is how you can achieve drift remediation, right? So you can make sure that your instances don't drift from their intended state. Creating an association, you'll see a lot of common concepts here as well. You start out by calling create association. You give a document name, give a target. In this case, I'm giving a tag query, right? So in this case, unlike the Run Command example where I was targeting a specific instance, in this case, you can see that I'm saying that everything that has a tag key equals name and value equals web server, apply this association to. And then I give an optional S3 location where I can keep all my detailed logs so I can go and grep and I can see what are some of the detailed execution results. So what this command, for example, will do is it'll configure all my instances that match that tag query to apply the document, web server document, which can really contain a bunch of things like configuring software or checking firewall ports or whatever else you want, and then applying it against that target. Switching over, I'll speak a little bit about Parameter Store. Parameter Store helps you centrally store configuration data. So I'm sure some of you have had times where you've had SQL connection strings or passwords or other important information that you have to pass every time to your script or to your nodes. Using Parameter Store, you can centrally store all that information, and you can reference it throughout Systems Manager. So for example, if you're creating an association using State Manager, or if you're sending a command using Run Command, you can reference the parameters in one place and manage it in one place. Parameter store is also integrated with AWS IAM, which means that you can do permissions on parameters, and you can say things like, just like with a document, you can say things like, this person or these users have access to these parameters. So that way you can control and lock down who has access to your parameters. And the last point is around storing sensitive data. And the way we do that is we use KMS. And we provision a default KMS key on your account, or you can bring your own key with KMS, and then we will encrypt if you use the secure string option, which I'll go over in a bit. And then we'll encrypt it, and you can reference it later on. Getting started with parameter store, fairly simple. You start with, you create a bunch of parameters, and it's a key value pair. There's different types of parameters. There's a string, a secure string, there's a list. And you can reuse, like I mentioned before, you can reuse parameters across your systems manager services. And here's an example of how to create a parameter. Let's actually skip this, and I'll go a little bit more in the demo. All right, so let's switch to some demos here. All right. OK, can everyone see font size OK? Yep, OK, great. So here I have a CLI. And what I wanted to do was I'll just run through some of the concepts that we've talked about to hopefully stitch things together. The one that I've highlighted right now is how I describe all the instances that are managed by Systems Manager. So in this case, you'll see that it returns a bunch of instances, a number of instances that I have registered, and the same metadata information that I sort of went over earlier. Things like, is the agent version latest? What is the platform? And other things. I can also do queries against tags. So for example, I can say, show me all the instances that match tag key equals ASG. And you will see that it returns all the instances that have that tag key. And this is the same querying and targeting logic that send command and create association also use. Let me switch over to the console, the UI, and show you how some of this looks in the EC2 console. So to start with, Systems Manager is in the EC2 console. So if you come to EC2, you will see right after auto scaling, there is System Manager services and shared resources. So we've already talked about Run Command, and let me just show you a quick sort of tour here. So you pick a document, your intent, and in this case, what I'm going to do is I'm going to select a document that runs a PowerShell script. And I'm going to select an instance that is a Linux instance. So you can see here the platform type is Linux, and the instance is heart beating. And I'm going to run a command like get process. Now, the nice thing about Run Command is we've recently added support for PowerShell on Linux. As you know, Microsoft made PowerShell available on Linux, and we have added that capability in Run Command as well, so that if your Linux instances have PowerShell installed, you can run it very simply, just like that. So once you run a command, you get back a command ID that you can use to track the results. You can see it's already succeeded, and if I look at the output, you can see the results of the get process command that was run on the Linux instance. So that's Run Command. Switching over, let's talk about documents. So I've mentioned documents a few times, and let's look at one of the documents I've created. It's called test any port. And here, what I'm trying to do is I'm trying to make sure that my fleet does not have an RDP port or a specific port that I've specified open. You can imagine how this can be useful if you want to make sure that your UDP port or your RDP port is not open for a certain class of web servers. And if you look at the content of this document, you'll see that all it's doing is it's running a PowerShell script, and it's verifying if the port is open. And the other thing I wanted to call out here is, notice this. Here I'm using a reference, the two curly brackets, and I say SSM:myPort. This is actually a parameter. And you can see that I haven't actually defined what the parameter is. It is coming from the parameter store. So if I switch over to the parameter store, you can see that I've already created a parameter called myPort, and its value is some random value that I've assigned for now. So using a document and a parameter store, you can create these specific intent and these specific configuration tasks where the data is coming from a different store that you can manage and access control in a different way. Let's switch over and look into State Manager now. So now that I've created a set of documents and I've created a set of parameters to reference in those documents, I can use State Manager to define and configure my fleet. So let me go over some of these. What I have done is I've created an association that configures software. So for example, this particular association, the State Manager demo, which targets everything that has tag key equals ASG, installs Chrome and a few other software applications on my fleet. I also have a couple of other associations that I've created. One of them tests for a specific port, the RDP port, and one of them tests for a port number that's coming from my parameter store. And you'll remember that I specified a random number like 1, 2, 3, 4, just to show how it can test both positive and a negative case. And if you'll notice on the right, there's a status on the association. What this is telling you is for that intent or for that association and the target that it's applied to, what is the consolidated status? So for example, my software configuration, which was defined by State Manager demo, is successful, which means that all the nodes have installed and they are in their desired or intended state. The other document, which was the test any port, which you'll remember was port 1234, that has also succeeded, which means that there is no instance in that fleet that has the 1234 port open. However, if you look at the last association, which is the test RDP port, you can see that it has failed, which means that some of my instances have the RDP port open. And now let me show you how you can drill down and see which ones are in their intended state and which ones aren't. I want to go in the Manage Instances view. This is our central sort of UI where we go over all the instances along with a bunch of relevant information, things like their inventory, their State Manager status, and other pieces of information. So let's pick one of the instances, like my Linux machine here. And if I click on the Association tab, you can see that this particular instance had only one policy or association bound to it, which was it was collecting inventory, and that was successful. If you look at another one, which has failed, so like the first one where the association status has failed, you can drill down into the association list and you can see which specific policy failed. So for example, for this instance, you can see that the test RDP port has failed, and you can look at the output to get more information about what specifically failed and why. All right, so that was a quick tour of State Manager and parameters. The other thing I wanted to show you was the ability to use the CLI to get some of that same information. So you can see here I'm going to do list associations, which is our equivalent of show me all the policies and all the associations that I've created. So in this case, if I just scroll up a little bit, you will see the same information here. Let's take a look at this one. I have an association with where the document or my intent was to collect software inventory, and it has succeeded. It gives me the association ID, which I can use to get more information, and it tells me what is the target of this association. In this case, I have bound this to a specific instance ID. Similarly, I can also find the detailed status for a specific instance. So right here, if I do describe instance association status and I give it a particular instance ID, it will show me that consolidated view of what are all the associations or policies that were bound and what is their status. And I will just, one other thing I wanted to go over was parameters. Using the CLI, I can do a similar operation on the parameter service. So for example, I can do get parameters, and I'll give it the name of my parameter that I just specified, my port. And it'll give you the type. Like I said, there's string, secure string. It gives you the name, my port, and it gives you the value. And you can use the put parameter API to insert or put new parameters into your parameter store. All right, so with that, let me switch back on to the console and show you one final thing, maintenance windows. So maintenance windows, I don't know if you remember, we talked about this very briefly in the beginning. Maintenance window is one of the services and capabilities we're adding in Systems Manager, and using a maintenance window, you can schedule run command to run at a regular interval. So for example, in this case, I have created a maintenance window that runs every hour, and it performs certain actions. And in this case, the tasks are, it runs a PowerShell script. And if you look at the history, you can see that every hour since I created this maintenance window, it has been running, and I can see very detailed information about what happened during that maintenance window. So for example, I can select this one, the PowerShell. I can view data. I can look at the output, and I can see that, okay, ipconfig was run in this case, what the results were. And if there was a failure, this is the same place I'd come back to look at the failure. Run command, as I mentioned before, also allows you to store output in S3. So what I wanted to do is just go to the S3 console and show you what State Manager and Run Command output looks like. So here you can see that I have been running my associations against a specific instance, and all the times that it has run, you can see the results here. So for example, remember how we were configuring software on the box? You can see that I installed Chrome. I can look at the output to see what exactly happened. So you can see that it was trying to install Chrome. In this particular case, Chrome was already installed, so it just did a check, and it just returned saying, already present, no action needed. If Chrome was uninstalled by someone on that particular instance, it would have been reinstalled. Similarly, Systems Manager is also integrated with CloudTrail. And this is very important from a auditability and compliance perspective, so you can see who has been running commands or associations or performing actions against your fleet. So if you look at this example, I just copied this over from the CloudTrail logs. You can see that in this case, someone performed a list command invocation API. And you can get fine-grained information like what were the parameters they requested, what was the operation they performed, what time, and so on and so forth. And with that, I think we are done. So thank you again. Thank you, everyone. Just to recap, thank you. Thank you. So just to recap, Systems Manager is generally available today. It is available in multiple regions, and everything that we talked about works on Windows, it works on Linux, on EC2, as well as on-premises environments. If you have any questions or if people have any comments, feel free to just stop by. We'll have an informal chat. And before everyone heads out, I wanted to introduce one more person. Anant, if you can please stand up. Anant is a product manager on the team, and he was very helpful in helping us get all these demos and presentation and everything set up. So thank you, Anant.